As promised, this problem is for you to try, and it is one of the assigned homework problems. It's number 45 from your textbook. Okay, so in a moment you're going to pause the video and try to sketch this. You might be comfortable going right to the final answer and skipping the working graph. If you are, that's fine. If you're more comfortable doing the working graph, that's fine too. Go ahead and pause the video. Give me a graph. I'm going to go ahead and draw a working graph for this. But once we've done that and we've got our final graph, I'll talk about how you might have been able to see that was the final answer and skipped this step of showing the working graph. All right, so this first one, my boundary is just x squared plus y squared equals 9, and that's going to be a solid curve. Now I recognize that that's just the circle of radius 3 centered at the origin. We want to shade where x squared plus y squared is bigger than or equal to 9. Now if I choose the origin as a test point, x and y are both 0, square them, add them together, I still have 0, that is not bigger than or equal to 9. So I am not shading inside this circle, I would be shading outside the circle. And I'm just going to sort of shade like so. All right, now my second inequality, my boundary is x squared plus y squared equals 16. And again, that's going to be solid. Okay. Now, that's just a circle of radius 4 centered at the origin, like so. And now I want where x squared plus y squared is less than or equal to 16. If I choose the origin there, that's going to give me 0, which is less than 16. So we're shading inside of the red circle. Like so. Okay. Now, this graph is kind of busy. If I take a look, though, my two boundary curves were both these circles. They were what we call concentric circles because they have the same center. They were both centered at the origin. And we wanted the region that was inside the bigger circle, which was the red one over here, but outside of the smaller circle. Well, that's the donut that we get right here. And in this case, I do want to include both boundary curves. That smaller circle is included because it was a solid curve for the first inequality, and it's inside the red circle, so it got shaded in red as well. The bigger circle is included because it was a solid curve when I graphed that inequality, and it's outside of the bigger circle, so it got shaded that first time as well. So this is my solution set. Now I mentioned at the beginning that you might have been comfortable going right to that. You can sort of recognize both boundary curves are going to be circles. So you can see that. And then if I want bigger than or equal to something, I can see that's going to be on the outside of the circle. Less than or equal to something, that was on the inside of the circle. So we get the region that's between the two circles. So if you saw that and went straight to this, that's totally fine. If you found it easier to see by graphing them each individually, that's totally fine as well.